There we go.
Okay. Does that mean we're live?
Yes, we're recording. Enjoy.
Okay. Hooray.
Oh, I've got to slump down because my torso is too big.
James. How you doing, James?
I'm alright.
Okay.
Do you want to move along a bit?
Yeah, maybe a bit.
You can come this way.
You
It's
can
alright,
also
there's
move along.
space here.
You can also move along.
Cannot. There we go. Oh, wow. You were just taking up the entire real estate of this. Okay. So welcome to NAPC.
Yeah.
Yay.
Okay.
A happy deuterocanonical podcast.
Deuterocanonical podcast, indeed, Brendan. So,
I'm sorry, I'm just fucking texting.
you are indeed. I really appreciate that you decided to start this professionally and then immediately.
It's gonna be super professional now.
So what are your thoughts on NAPC?
It's badly organized.
Okay.
Mine started with me getting hit by with a drink from a passing car. So, hooray, California!
Yep. It could have been worse. There could have just been needles in that.
Well, I was gonna say it could have been a glass bottle.
Yeah. Just a very hot bong.
I think most people who tended to come were able to come though, unlike last NAPC where it was an enormous blizzard.
Oh, was it?
When
It was
did that?
in
It was in February in Florida.
And they were like,
Oh.
everybody's going to want to come to Florida in February. It'll be awesome. And then there was an enormous blizzard from like Ohio all the way to Maine. And my first flight was canceled the night before. So I drove through Pennsylvania in the blizzard to make the Philadelphia leg of my flight. And then they canceled that flight. And then I
Wow.
caught a van of people going to NAPC, going down the East Coast.
You were committed to going to NAPC.
Yes. I did miss my talk though.
Oh,
So
just
Lauren
busted
gave
it.
it.
Oh.
And then they had a session that was all the people who got snowed out of their talk and couldn't go the first day. And they had a session that was just the snowed out people on the last day. And it was awesome because like nothing went with the next talk. So you got to hear about just like tempestites and then Ediacaran things. And then it's like, and now we're going to do genetics of clams, and
So it was just a grab bag of awesome
it was the
things.
most NAPC-ish thing. It was like, and now a vertebrate, and now a clam, and now it's just like,
I guess because nobody knew what to create extra, you just sat in the room.
yeah, it was fun. It was a fun session.
So we saw talks today?
We saw talks today.
Okay.
Sorry, I'm now not texting.
Yeah, no, now you're just flipping through your own Twitter feed to look and see whether or not people are liking your tweets.
No. What I'm doing is, instead of taking notes, I live tweeted, so I need to see my tweets
Right,
to see what I
of
thought of
course.
talks.
Of course.
I'm a man of the people. I don't
Yes.
Keep information hidden in notebooks.
Spreading your note information out to the world for everyone to retweet.
Heather got the most tweets. So,
So is that where we're starting?
no, we're going to start with the fact that they had a pizza party yesterday.
This is not a talk.
It can be.
No,
This is my TED talk about why pizza is the worst food to do for everyone.
No one will attend this TED Talk.
That's okay, that's a standard TED talk.
You will have 0 views on your YouTube video.
It's not my YouTube, it's TED's YouTube. It's their fault for booking me.
That's fair.
So who wants to start?
Well, we went to the same talk first. Went to the Marble Canyons. And
Yeah, we did.
Yeah, I'd like to hear about the thing that I've probably seen before.
That's what it was.
Okay.
It was an advertisement for talks later on in the week, so we might come back with more about that. But essentially, there's a new locality that they're looking at for all these Cambrian fauna stuff. So again, very nice preservation. And there is one fossil bed that gets lots of this material from, and they show all the spots on their site where they can get fossils from. But actually getting to the actual rock is a problem.
Mm-hmm.
So a lot of the stuff is in float. And then they get to the rock, but the rock's on a cliffside. And then they're just like sitting with a big saw and just cutting into it.
I think I've seen this film. See, that's one of the Fast and Furious sequels, right? The rocks on a cliff and there's a giant saw.
Yeah.
But they had quarry, The quarry was about the size and shape of this couch.
But up on a slope. And so they had a bunch of people huddled over, like 6 people just huddled over this mass of this rock that they had exposed.
Digging down into it, getting lots of cool stuff that we'll hear about later in the week.
Was it just like there was a slide and then occasionally entire words were just blackout redacted?
No, but there was like, here is a very much out of focus picture of a blob, and this is something that's very cool that I'm not showing you because it will be published in a year.
Okay.
And then a picture of a grizzly bear.
And talks that are on Wednesday with peers. And a student is describing this in a talk on Wednesday.
And then a really good animated GIF of people moving into tents and closing up for the night on the acknowledgement slide.
Yes, I enjoyed the animated acknowledgement slide.
Yes.
Time lapse of camp closing down for the night.
It's not as good as my animated acknowledgement slide.
We haven't gotten to yours yet.
I've seen it. It's a thing.
Don't go to my talk.
Please go to James's talk.
Don't go to my talk.
So James, what's the first thing you want to talk about?
I want to see Peter Smith's possibly last talk ever.
Oh, okay.
Leaving academia, writing a textbook on how to do code.
Oh, okay. I did not know that.
Yeah. Open source textbook on how to code.
Yeah.
Basically, is what his party gift, as he called it. He was talking about predicting extinction.
Yeah.
And taking basically range data and doing a lot of stuff that went over my head. But he was basically, the assumption being if you've got a broad geographic range, you're less likely to go extinct. If you've got a smaller geographic range, you're more likely to go extinct.
Okay.
But the thing that hadn't been done before is because he's going million year by million year time slices, he's allowing the range to change through time.
Oh, cool. Okay.
Which hadn't really
so
been done before.
you're not accidentally averaging something that might have a small range, but just moves its range over time.
And then the question that he had was, when your range changes, does your probability of extinction immediately change? And the answer is, you can't tell.
Okay, I kind of figured it would be.
It's real hard to predict extinction because maybe more things than just range size go into whether or not you're going to go extinct.
Well, sure.
No, this is him. I'm not being sarcastic. This is his talk. This is what he was saying.
Yeah.
And he had like high, low, fair degree of accuracy, and a lot of this is like it's fairly accurate, and fairly accurate means 75%.
That ain't bad.
Yeah.
I mean, hey, for ecological parameters, predictive capability, 75% is pretty good.
But he had different things where the stuff covary, do you make geographic extent constant, you're allowed to vary through time, and the most accurate thing is allowing it to vary through time. But the main upshot of his talk was, I use million year timescales. That's probably too broad. Like, the thing that causes your geographic range to change is sub-million years, and the impact is sub-million years, and so it's too coarse a scale for trying to predict extinction. It happens in generation times, and so it's populations dwindle in less than 1 million years to extirpation.
Rapid extirpation.
Yeah. And that was the upshot of his talk, basically, and it was very cool. It was, a lot of it was beyond me, but it was really cool.
Yeah.
So.
We saw a cool talk on foraminifera and changing climate and the potential for foraminifera or for microfossils as a good way of showing when the ocean's biological pumps shut down in the past, and all these kinds of cryptic extinction events that we might not be acknowledging because we're not always looking at what's happening in the foraminifera and the diatoms, the radiolarians, and all these micro and nanofossils.
And also how diatoms, being heavy things that photosynthesize, are carbon pumps. So things that are bad for diatoms are then potentially bad for the whole carbon system.
There was a cool handoff too, where there was shifts between radiolarians and diatoms, and both of them are capable of pulling in silica from the water, and they use that to secrete little skeletons. So these are all plankton that are floating in the water. And when there's a shift that what hurt the radiolarians, the diatoms started doing better.
The diatoms were doing better.
But they were pulling in more carbon than silica as well. So the thought was that maybe there's some sort of silica depletion in the water and the radiolarians are suffering, but the diatoms are capable of doing things to kind of skirt it and get by.
Yeah, because the radiolarians became more diverse slightly earlier, and then the peak for the diatoms was slightly later. It might be that as they started to deplete silica in the water, the
Yeah.
diatoms were more efficient at the lower silica.
Yeah, which is cool. But all these microorganisms, these plankton, can be negatively impacted by changes in sea chemistry and changes in temperature. And so one of the thoughts that he had was he was looking at the temperature biases and all these cold water diatoms, which are very important because when you're in the cold water areas, particularly in parts like the North Atlantic, the high productivity in those regions and the cold water allow for carbon dioxide to sink into the oceans very easily. That's where the oceans kind of breathe in their carbon dioxide. And then these photosynthetic organisms, they take in that carbon, and then when they die, they sink down to the bottom of the ocean. At least some of them do, a small percentage. And that's a leak that pulls carbon dioxide out of the surface water, which usually would just go right back up into the atmosphere very quickly, and puts it in the deep ocean where it's kind of kept for much longer.
And another extension that he did from that was because you have a coupling of the diversity of these diatoms and the total mass of siliceous material that's being deposited, there's a relationship between diversity and total export of carbon. And so if he said, well, if, like, let's just say this is a linear temperature diversity relationship, because it looks fair over the Cenozoic. If we add 1.5 degrees, what's diversity look like? And it's like, and we've got all the way down here. So potentially that means that as it gets warmer, diatom diversity will go down, which will make it harder for carbon to get out of the atmosphere and export to the deep ocean.
Yeah.
And it will get warmer. And equilibrium will be a much less diverse plankton.
Well, yeah, because the major issue is if you can't get it out of that surface ocean within, I think, about 9 years' time on average, that carbon just makes its way back into the atmosphere. And so it's not a really long sink. And so right now, the oceans are taking up a significant amount of carbon dioxide from emissions. But if we significantly impact the biological pump, that means we're going to deplete the amount of carbon dioxide the oceans can take in, added to the fact that also warmer water takes in less CO2.
Mm-hmm.
So that's
and it's harder to mix into deeper waters in the Arctic and Antarctic too, as you start to get a more stable.
Yeah, you potentially shut down some aspects of the ocean mixing.
So the physics and the biology and everything is saying it's all positive feedbacks.
Yeah,
there's no
when the systems align like that, it's kind of worrying. So yeah,
and then I did spend the rest of the afternoon in almost entirely in the Antarctic session.
That sounds very, very cool.
Yeah, it was a lot of similar depressing news.
Oh good. I'm happy. Every single time we're feeling too good about ourselves, we'll just ask you how your afternoon went. Yeah.
The penguins.
Okay.
The penguins, James. Legitimately, there were penguins, and it was sad. And there's new penguins.
Penguin Novo.
Penguin Nouveau.
No, not Nouveau. It's things are starting.
I know you want to take Novo, but I prefer Penguin Nouveau. I'm just imagining some soft pastel colors.
There's a bunch of talks commenting on a bunch of things that are now moving from temperate southern hemisphere into Antarctica.
Oh, because it's now temperate southern hemisphere.
Yeah. So there's penguins that are temperate that are Gen 2 penguins are bad for the Adelie penguins.
Brendan, penguins or penguins, please.
Penguins.
Yeah.
Penguins.
Yes.
I didn't know I was playing Benedict Cumberbatch for this.
Yeah. That's actually that's who I hired you as.
Okay.
So.
All right. I'm looking forward to when I get to be the voice for an animated Eurypterid.
Oh my god.
But then you're going to be in a film where you're going to have to do a real bad American accent.
Yes.
Okay.
But you'll get an animated cloak that everyone cheers and then cries over when it dies. Yeah.
I mean, I cry over my clothes when they die.
That's fair.
We probably shouldn't talk about everything because it doesn't need to be 1 million hours long.
There's a lot of things, and yeah, we should probably pick highlights.
No, I just think I just summarized the Lintox talk and several other talks in the Antarctic session, but it's bad.
I think you should probably pick one that you really, really like.
Well, do we want to talk about Heathers? Are we talking about Heathers or
This
exempting
seems
Heathers?
really weird with her in the room.
She's in technically a different room.
That's fair.
Yeah, it was a cool talk.
There is a door. It was cool.
There is a door.
There's a door. It's a separate room.
I thought
Metaphysical door.
I thought the only thing that needed to
physical
be
and
said
metaphysical door.
was read the geology paper and then
Yeah.
drop the microphone.
Yeah.
Yeah.
And it's such
Yeah.
just like to explain a bunch of stuff and make it seem like her work was really important and interesting.
Oh, okay. I guess you should do that.
Yeah. Actually, it'd be real good to just drag her and see if she'll come in.
That's not gonna happen. She probably has headphones on right now and
Yeah.
the door's closed.
Yeah.
It's open, actually.
Oh, okay, never mind.
She
Oh,
doesn't
so she is in the room.
She doesn't want to interact with us. It's okay.
I think it could be done if you try hard enough.
If you're thinking if we do this? Okay.
Well, she
I said
peaked
try
early.
hard enough.
You gotta try hard. Are you calling us tryhards?
I've never tried hard at anything. I'll have you know. No, she peaked early. Too early. With pictures of dinosaurs dying.
And then saying we're not talking about stupid dinosaurs. Well, she didn't say stupid, but we're not talking about dinosaurs. We're talking about
Yeah. And then
foraminifera.
made some case that Calcareous nanoplankton are actually really important because they're primary producers. They're totally wiped out almost.
I made the important and neglected PSA that Carbolithophores are not the only calcareous nanoplankton.
Yeah, that's important.
So it's obligatory to actually say calcareous nanoplankton.
Yes.
Yeah. And if you take them away, you have major ecosystem restructuring.
Really?
Yeah.
Oh, fascinating.
And then almost like it takes millions of years to recover from that.
That's just no. I think once we hit past the carbonate compensation limits of the oceans, it's just gonna be fine.
I mean, we'll have all the calcareous we need.
3 million years, right? That's a reasonable amount of time. It's closer than the coral time scale.
Yeah.
3 million years.
Yeah, 3 million years. So we'll get this restored homogeneous plankton in 3 million years, right?
Sure. Yeah. Uh-huh.
Yeah.
We're accelerating ocean acidification faster than the PETM. Have you seen the cores for the PETM? It's terrifying.
Yeah. Antarctica bad. Antarctica bad. Here's 5 pages of Antarctica bad.
It's okay.
Brendan, we were a little too high on ourselves talking about how really fun it was watching those dinosaurs die. Brendan, why don't you tell us a little bit of just a factoid about how Antarctica is bad?
Okay, yeah, no, this is good. Actually,
I like this.
Yeah.
I like the Brendan depresses minute.
Yeah.
Okay, so the leopard seals would come and there'd be the thing that they drop air horns into the ocean to get the divers to come out when they see the leopard seals. That it's like, but we should feel bad for them too, because there's a whole bunch of upstarty seals coming in also, and then there's other seals, and it's all about...
Do people have to run away from leopard seals?
People do have to run away from leopard seals. The divers have to come out if they spot one anywhere.
I mean,
they just kind of spiral in. They said they come closer each time, and then they would attack you.
Okay.
They're real friendly, but they have the skull like a tiger.
Yes. And then other seals that pop, they have teeth to cut through the ice so they can make their own like hole in the sea ice somewhere and pop away from the leopard seals.
Okay.
And now as the sea ice is retreating, there's less and less space for them, and it's like, and here's things that we've never seen pop on a beach, but they're starting to hang out on beaches.
Okay.
So we've been watching to see if any of them are able to have pups and rear them on a beach, but it's the first time ever that they're starting to like show up on beaches.
Walruses and stuff like that.
Mm-hmm. But Southern Ocean fur seals are starting to come down, and more frighteningly and more smelly, elephant seals are starting to show up at the camps, and they're at the camp, and it's the worst smelling thing. This was a component of a talk.
Okay.
So they are seals.
Nice.
Lovely. Do we want to do volcanoes? Question mark.
We never actually really talked about the details of Heather's talk.
We didn't really.
We talked about it. We said
Plankton takes a long time to recover.
3 million years.
So you get this north and southern hemispheres.
That's actually that's something that's very important.
And the Chicxulub crater, while it's a little bit delayed, just follows the northern hemisphere trend.
Yeah.
And then after 3 million years, the parts are recombined, and it's whole again. And then things are better.
So to put that in perspective, like if we run 3 million years ago, you could still, in some places, maybe swim through some shallow channels from the Pacific to the Atlantic. Megalodon was still happy. They're not still alive.
It's a little over 3 million years ago. I looked this up mostly because of the shark talk and our humorous idea that Megalodon evolved and ate all the other sharks.
No,
we'll get to that.
my idea is whether it was just part of the extinction. Anyway, yeah, and when the southern hemispheres are the same again, that's also when the biological pump starts up, so that it's healthy again. Okay, cool. We got through that talk. It was great. We ruined it.
Like everything we do. Volcanoes.
What about volcanoes? Do we want to talk about Eurypterids?
Oh, there was the Eurypterid talk. James, how do you feel?
It's revisited. It's trying to test. It's trying to test an old idea from the 1930s that Eurypterids and early vertebrates were in competition with each other through either predation or competing for food. There's possibilities they were interacting. I think I'm not mischaracterizing the talk where basically it's a case of we really need data.
Yeah, no, I don't think that the talk was in any way like. I think they were very upfront. I think they were very upfront about that.
Yeah. So we need data. The one interesting thing is that I didn't realize that earlier strachoderms, the juveniles, have almost no dermal armor and they grow it as they get bigger. So that was cool.
Yeah, early proto-fishy fish things.
Yeah.
Early vertebrates.
Yeah. And that was basically that talk. My personal view of it.
There were two fossils that had holes in them. My
overall view is that they probably did interact, whether or not they impacted each other meaningfully in terms of their macroevolution.
Yeah, of course.
But yeah,
if they're living in the area and they're small enough to be eaten,
mm-hmm.
I mean, there's that idea has been so.
Wow! I've just seen this tweet. I tweeted out juvenile lawless vertebrates like double armor.
Lawless vertebrates.
Oh, that's good.
You immediately then
did they get
tweeted
for being in the ocean without
he immediately then tweeted the picture of the sun. So
no,
I think
that's an hour later, and actually I'm going to tweet this tomorrow. I'm going to Photoshop on the face from the Mario sun.
Okay, that's good.
Then I tweeted a giant burning ball of gas from the sky, and
named it Ted.
And then lunch.
And then there was lunch. I'm cool not talking about that.
Yeah, there were some cool. There were lots of Lagerstadt talks of just really cool fossils.
Yeah.
But there's not really anything you can do on an audio podcast to explain a really cool visual fossil.
Brachiopods had pedicles.
There was the one that was kind of cool was the one that had like almost ribs of setae that were like running just like cones across parts of it. That was very interesting as opposed to just the hairs going all across the edge.
Yeah. Did you have?
What do you look?
Ocean acidification and arthropods.
Oh yeah, no. Let's definitely hear about that. Let's get depressed.
So they took some of the macroalgae and they did mesocots. No, a bunch of different things.
Okay.
All things that end in pods.
Okay.
And they took some macroalgae from Antarctic and put them in mesocosms and did them under different future acidity regimes. And at the end of the century, slightly more, not so good.
Okay.
And then they did say that it was done just the acidification and not with future temperatures. And they did future temperatures kind of separate, and the acidification was way worse for them than the temperatures.
Oh, okay.
The dominant component was the acidification.
Interesting.
Let's see. Oh, I have the unhappy life of arthropods bombarded by dropstones was a quote from a talk.
These are just arthropods that are living outside on the edge of the shelf ice, and they're just constantly getting pieces of.
This was a northern hemisphere. This was fjords.
Okay.
And it was doing ichnofacies associated with Arctic climates and what combinations of things did you get? And it was because a lot of it was the salinity, because you had the near ice, then you had the freshwater melt influenced kind of brackish environment, and it was trying to look at what kind of characterizes cold climate sea. There's a few things that we're looking at what can use as proxies for sea ice.
Okay.
And this was a fun one because it was a bunch of it was trackways with drop stones. And it was and that could have definitely squished that one because it just ends. It was a whole set of trackways, and there's 4 or 5 drop stones in this field of trackways.
I like this being almost like the beginning of Dante's Peak, where they're driving and the volcano bombs are falling everywhere.
It's slightly slower motion from drag.
So when they did Blue Planet 2 a year ago, they were filming cold water coral reefs, deep water cold water coral reefs, and they're in the ROV. Well, I don't know if it's an ROV because people were in it, and they're down recording. Of course, there's sea ice overhead, and there's just this constant sound of things pelting the top of the submersible. And they're just going, if one hits it big enough to crack the glass, we're not getting out in time. We're dying down here. There's just this constant pelting of stuff being dropped from the bottom of the ice as it goes overhead.
Till is a wonderful thing. You have no idea what size it's going to be. Speaking of things falling in Dante's Inferno, volcanoes?
Yeah, the volcanoes is probably the next talk to talk about. We can skip these two.
Yeah.
The Devonian, why?
Yeah, the Devonian, why?
And at the end of the Devonian, where there's a big mass extinction.
Yes.
Why?
Why? Why?
And they find,
I don't know. I didn't see the mercury talk.
Yeah,
Is it mercury?
There's lots of mercury. Well, there's not a lot of mercury because when you set your reading cut off to be too high, you don't find any mercury, and then when you change it, then you find mercury.
You find a fair amount of mercury, actually. That was a really good start to the talk.
Yeah, it's kind of like if you're trying to count the number of people in a room and there's one person, but your threshold is there needs to be 1.5 people to count anything.
Yes.
So they found mercury after recalibrating how much mercury you might expect to find.
And so they find this in a site in Vietnam. They picked Vietnam partly because it was far away from a lot of known provinces and sort of in an area that was very deep and far away from a lot of terrestrial influence. And it's a very compressed section because it's so deep and there's so little sedimentation in this area.
And they find some mercury, and they've now found mercury at 4 other places and counting.
And they are increasing the number of sites there globally with their distribution on paleo maps around the entire globe. And this particular part, which is the Hagenberg, because this is the second pulse, right?
Yeah, it's the terminal Devonian pulse. And so after this, we are into the Carboniferous. Yes. Well, not quite immediately, but then you're into the Carboniferous.
And there does seem to be an abnormal spike in mercury.
There's mercury, and often that is tied to the eruption of large igneous provinces.
Well, because mercury is heavy, and so mercury can be found with the heavier stuff.
Comes out with lava.
Yes.
But there are no large igneous provinces.
Yes.
So what's causing it? And the answer seems to be, well, there are lots of things that cause mercury, but one of the possibilities is it's other types of volcanoes or volcanic eruptions that are creating stuff that is not going to actually give you a record of the
essentially mostly ash deposit, mostly ash and soot and other pieces of rock coming out that don't leave big bodies of magma deep underneath the ground that will either again erupt to form the flood basalts like what you see in the Deccan Traps in the Cretaceous, which we talked about on the podcast, or like a lot of the mountains you see in California. They're eroded out what we call batholiths. They're just big granitic or andesitic rocks or dioritic rocks that cooled underground because you have a big block of magma or glob of magma that cools slowly over time, and eventually you just harden it into a big thick rock. And then things like the Sierra Nevadas are just that stuff uplifted and eroded out. The La Salle Mountains also in Utah. But we don't see big igneous beds, or no, not beds, but the igneous rocks don't form beds. We don't see big igneous blocks of rock at this time period, and that's the weird thing. So it's got to be, if it's volcanoes, it's got to be a very special type of volcano that, sadly, by mostly giving giant ash clouds, isn't going to leave much of a record, which does leave us in this kind of interesting shrug state where we're seeing this significant geochemical signal, but it's not very easy for you to get a smoking gun because it's not going to, the thing you are looking at is not going to leave a very significant rock in the record.
Yeah.
And so they ended with the only meme they could end with. I'm not saying it's aliens, but it's aliens.
I nearly cut it with a real bad joke. So.
You're going to go milkshake duck?
No, Pepe.
Oh, no. You milkshake duck this podcast.
I did. Well, it's good because I can't have milkshake, so milkshake's bad. No.
Fair.
So the only other thing that I'll talk about is sharks. So do either of you have anything else?
Aside from seals, also crabs, also salps, also lots of things are
these all
coming
things
in.
that are
Salps are replacing krill. And
really
they describe
this.
that as whales having to eat lettuce instead of eating burgers.
Okay.
That was the metaphor for salps replacing krill as Antarctica gets unhappy.
Okay.
And let's see, more bad animal things.
You got a real robust psyche.
Just
the fact that you were able to sit in that session and just not cry, just constantly.
And then we did Dana's talk, where she talked about the 40-year data set that's been collected on Appledore Island of transects, and the attempt to see if, because the rocky intertidal is very rarely preserved in the fossil record, how much of it makes it into the death assemblage in the sandy nearshore subtidal.
Yeah.
And the answer seems to be you can't really use the sandy nearshore as a proxy for the rocky intertidal at all.
Okay.
But there's
it's important
40 years of data collected on Appledore that's all been in legal pads of people counting what people found on transects that Dana digitized and was able to do stuff with.
Mm-hmm.
So that's cool.
So a case of converting dark data into sort of useful data.
Yes, yeah. And also there's comparison to temperate to tropical because they had the stuff from San Salvador.
Mm-hmm.
Just realized that we have this on the couch.
Yeah.
Yes, and here's an unsolicited advertisement for a good book.
It's audio podcast for the people who aren't watching the video, so good job.
No, that's fine. That's fine. It's on brand.
It's on
you could pay extra to find out about something else you could pay money to get.
It's going to get released in the end with everything else, too. Okay.
We will give everyone a PDF copy of that. No, we won't.
We'll give everyone a PDF copy of this video.
Of the cover of the book.
Yeah, I can do that.
Kelly Cronin.
I still think that's copyright infringement. You're taking the copy anyway.
It's an ad. It's a free ad.
Yeah. I mean, Amazon does it.
Amazon's selling it. Amazon is a bookstore. You are not Amazon.
I have a copy. I'll sell it.
That is also illegal, technically.
Technically, it's illegal to resell a book. Just so you know. Just so that immigration knows, I've never resold a book.
It is technically, but there's also eBay. There's plenty of ways you can.
There's a lot of illegal things on eBay.
You put the book into a trust, and then you transfer control of the trust. And if necessary, you make it generation skipping, because that's how you get out of everything if you're rich enough.
So how much more of the Arctic is screwed?
Oh, no, I've moved on to...
Oh, we moved on, okay.
Also in Antarctic, but last talk in the Antarctic.
Oh, okay.
Kelly Cronin talking about using combinations of laser ablation, ICP-MS, of different elements to track in scallops larger year melts of sea ice because of other elements like lead getting released from the ice that get incorporated into the shell. So on these deeper water things that aren't influenced on the every year time scale, and then counting the growth bands that are visible in the shell, going there's about the right number in between for this one to be the 2012 extra large melt, this one being the 99 extra large dispersal of sea ice chemical tracers, and so tons of elements, and then doing wiggle matching in sciencey ways of doing wavelet coherence, which made pretty diagrams of heat maps, and then
So
being able
this
to
is
put
almost
actual confidence intervals on wavelet matching.
Is this almost like running through like a series of like stacked Taylor series or something to just approximate like very complicated functions? Is that?
It's
like
about
me having like a 5% knowledge of the thing that I just said.
It's an evaluation of how well the waves cohere. If you translate like how close are these to being in the same pattern.
Okay.
And doing magnesium and lead and iron and seeing what goes together. And lithium was a proxy for something that I think it has to do with diatoms, but I don't know why. But apparently lithium is a proxy for diatom blooming.
I mean, at the very end of this session about the Arctic, I think lithium is probably appropriate.
Yeah, it was a good end.
So does that mean we could take diatoms and compress them into batteries?
I don't know. We haven't gotten that desperate yet because nobody's paying attention to what the strip mining for lithium is doing to the local environment.
Yeah,
We're
so
just
here's the
super
lesson
excited.
for people at home: don't replace your goddamn phones every year.
Oh, and use those drops. The drops for recycling the batteries for phones and for laptops. Do
Hoard
that.
them, be mineral rich and land poor.
So do we get to end on Cluedo, but for sharks?
Yeah, and it genuinely was, because I
Yes.
was working it out as she was going. It was fantastic.
Okay, so Cluedo for sharks.
Yes. Who killed the sharks?
Yeah.
Which
First of all,
sharks?
did you know the sharks died?
All of them.
Almost
all of them. So for a large part of Earth's history, once sharks had evolved, there were many different types of sharks in the pelagic realm.
Which, I mean, we've talked a lot about that. Like,
Yeah,
there's...
Helicoprion,
Yeah.
and anvilhead sharks.
Yeah.
It's all cool.
Yeah,
There
at
was
least
diversity.
one of those isn't a shark, but that's okay. Helicoprions are chimera.
Oh,
Yes. Next, you'll be including scapes and rays.
I am. Look, it's the rays and some of the lobby-toothed sharks all eat my mollusks,
But
so they're all in the
Did,
same.
did you know that in the modern, there's actually surprisingly few sharks in the pelagic realm? Well, in the open ocean.
Yes. And this
Sure.
is all based on data from deep sea collections.
Yeah.
So you just take your sediments, go see what comes out.
And look for denticles, which are the skin scoots of the teeth on the
Because
skin.
clearly we're talking about sharks, and unfortunately sharks do not have big, hard skeletons. They have teeth, and they have denticles, little scales, but they do not have skeletons, so it's very hard for us to preserve lots of shark fossils.
You do occasionally get a real cool shark skeleton.
Yeah, occasionally,
Yeah.
but it's very rare because
Yeah.
cartilage doesn't fossilize so easily.
Yeah. And it's the big trunk ones that seem to do it more often, like
The giant megalodons, jaws, just in general too.
But there's like an almost complete Cretosaurus,
Okay.
and I've seen there's a real nice sort of great. It's either a mako. There's literally almost a great white jaw and vertebrae, and it's the vertebrae that tend to preserve as well. But yeah. And so when did this change happen? When did most of our open ocean sharks get extinct? It was
19 million years ago.
Years ago.
So the thing that she does show, though, is that if you look at these denticles, there's lots of variety in the shapes, and she sees repeating shapes. So it's not just like these things are malformed or this is an aberration within the population. Like she sees these sorts of repeated shapes over and over again and assigns series of morphotypes and then compares the number of morphotypes that you see in the Cretaceous, throughout the Cenozoic, and then all the way into the modern ocean system.
So not only are they becoming much rarer 19 million years ago, the diversity also plummets.
Yes.
So there are fewer of them, and they're mostly the same type of thing. And the reason this is important is because what you're basically looking at is the structure that makes up the outside of the shark. And so these have biomechanical properties.
Yes.
Because they're interacting with the ocean, and it's life in moving fluids.
So that lets us break these up into two broad categories. You get the ones that are kind of wavy lines, and those wavy lines are sort of very similar to the kinds of lines that went into the suits that Olympic athletes wear for swimming, because they are designed specifically to break up the water and allow for long-distance swimming. But you also have other sort of more, what you refer to as geometric, but imagine a golf ball.
Yeah, and that is designed to fall good, basically, right?
Well, I mean, what a golf ball does is a golf ball can stay aloft in whatever liquid with very minimal effort, but it's not like a prolonged swim. It's not like keep that direction. It's all about keeping sort of micro turbulence next to the ball to keep it aloft.
Yeah. And so she looked at all the modern ones and how. And first of all, there's a lot more diversity in the modern than you'd think from looking at the fossil record. That's because most of the modern ones live in coastal waters.
Yeah, so
they retain their diversity, but they're not in the open ocean.
Yeah, so the comparing of the record, when you look at your modern sediments, it looks like there's very little things living in the open ocean. That's probably because most of these things are living closer to shore.
Yeah, and the ones that you are finding in the open ocean now are things like the requiem sharks that are just long-distance travelers. The exception being two groups of sharks that retain these geometric scales in the open ocean. And they're cookie cutters, which are fantastic sharks, and lantern sharks. And cookie cutters are little torpedoes, and by little I mean like 3 feet long, some of them. And they just find things swimming by, bullseye them, and then they just take a chunk off. And so you'll often see seals and whales and whatnot with basically a cookie cutter.
She had 2 pictures of great white sharks with little chunks taken out of their mouths.
Yeah.
Just nom right along the edge of the cheek.
But it's like a 3.5-inch biscuit mold that's just taken out. And they'll do it to swimmers. They'll just hit you, and then that's all I need. And they like whales because there's a lot of blubber, but they'll hit anything because in the open ocean you can't be fussy.
Yeah.
And so they're what made it through. And she did say that you can't be too uniformitarian about assuming that everything that's in the open ocean with this geometric thing was basically a lantern shark or a cookie cutter analog. They probably were doing other things as well. We just don't know exactly what they're all doing.
But the interesting thing that we do find is with all the ones with the linear, they are capable of fairly good long distance swimming. Yeah. And so one of the thoughts is that there's some event that happens, and what we're left with is a somewhat depauperate shark ecosystem that is maybe now moving from from near shore area to near shore area and traversing long distances.
Yeah. Because I wondered if we're seeing a knock-on effect from the rise of toothed whales. But then what she showed was that the rise of long-distance swimmers and things that were using the ocean for travel and food, like baleen whales and penguins, only occurs after this event. Yeah. And so there seems to be something, maybe a reduction in productivity or some way of changing the way the system works, that meant that it couldn't support this diversity of shark life. The only things that are left are the ones that can travel a long distance and have wide territories from which they can travel in and find food and whatnot. And then after they've gone, that's vacant niche space that is then filled by all these other things, but they also tend to be long-distance migratory swimmers. And so maybe the oceans, the pelagic system is less capable of sustaining things that only live in that system or only within parts of that system or something like that. Basically say something happened, we don't know exactly what, but it had this major impact on the way ocean ecosystems function that is the system we're now working in today.
Was there any talk about the ships with more mesothermic shark systems and swimming policy?
No, and I think part of that is because the data she's looking at is very explicitly the denticles, and you'd probably be taking a big leap and trying to tie all that together with the data that she's got. So, but I thought it was very cool, and it's basically a hidden, and we don't know if it's a selective mass extinction because she now wants to know other people that work on ocean-going groups. Do you see a similar thing at some time period?
And also, to some extent, this is looking at the deep ocean. And while she certainly showed that in all modern sharks that she could sample, there is certainly far less of these geometric scutes and sort of denticles, I should say. But it doesn't mean that it necessarily happened at 19. There certainly seems to be an event, but it also could mean that some of these things significantly moved out of deep ocean. So that can delay or smear things, but it's weird that the record seems to pretty solidly stop. Yeah. And you see it in both. So you see it in the South Pacific record. The North Pacific record has a massive gap in the record, which is problematic because it's right at the spot when the extinction should happen. And so you see a lot of things terminate there, but you see a lot of things terminate before as well.
I mean, it's interesting that you have a gap in that period of time and that gap is associated elsewhere where there's a good record with a potential extinction, because potentially something's going on.
Yeah, no, totally.
So yeah, that was really cool.
Again, that's a very measured interpretation, but I think, Megalodon evolves 23 million years ago.
So this
and
is
so
why...
it just is unique, James. We need a killer. We need someone that the audience can boo.
So the reason I asked when did Megalodon go extinct was because I immediately thought, what if the Megalodon extinction is just the one that we noticed? But Megalodon went extinct much later.
Megalodon was way more
because
recent.
it was preying on baleen whales, which do not evolve until after this extinction. But that was immediately when I rang. I was like, oh, what if we've already noticed this, but we only noticed it on the one that we care about? Yeah. But the timing doesn't match up.
No, it's roughly 3.5 million years ago is when Megalodon goes.
Yeah. When the small baleen whales go. And food supply seems to disappear. Along with the giant penguins.
The giant penguins.
The 6 foot tall penguins.
Do you think they'd bite off your head, or do you think they'd put his top hat on? Do you think they'd do both?
I don't think they have flippers. I don't think they could. They could maybe put a top hat on each other.
I saw Mr. Popper's penguins. They definitely put a on.
We should wrap before I get into more depressing penguins.
Yeah, let's
end on a
let's end on a depressing penguin story.
Okay, so it's getting warmer, as we know. That also makes it more humid if you're in Antarctica.
Okay.
So now, because it's warmer, they're nesting when it should be dry, and it's snowing, and it's snowing on the nests, on the eggs. And then when it gets warmer again, because it's supposed to be the warm times, they drown.
Oh!
And I'm legitimately teary now that I have.
Although I would say, I'll tell you the one thing I'd say for a penguin, that's very ironic.
That's very ironic.
Because of warming, snow is killing them. This might...
Snow is drowning them in the crib.
Don't tell anyone in the Senate.
On that cheery note...
Okay.
Everyone loves penguin crib death.
So can we please save the penguins?
Yeah.
No, I am very tired, but I am legitimately teary now. Some combination of tiring and...
I think that's jet lag and also penguin baby death.
Yeah.
Yeah.
I saw March of the Penguins. I've been predisposed for this.
Yeah.
I have a heart.
So is there going to be selection for penguins getting taller quicker?
It might... Maybe there's going to be selection for getting... different breeding season.
Yeah.
Because the breeding season's been very tied to climate, and it should be when there's no more snow.
What if...
It's not... It wouldn't have been when
they need food, though.
That's a different penguin, different problems. Again, going back to there's no sea ice, which means both the krill don't do as well because they don't have the sea ice to go through their teenage years. And then the penguins can't slide on their bellies for most of the trip to get to the further offshore.
That's got to be a really annoying waddle.
Well, I mean, that means penguins are going to have to stop going so far inland.
Well,
where the predators are.
Uh-huh.
Yeah, that's going to end well.
Everyone's going to be on the same little beach, and then we can watch the Netflix
They're going to be bowled
thing.
over by an elephant seal.
Yes. Which we'll all try to climb the cliffs. Or no, you know what? I haven't actually watched that thing that everybody talked about on Netflix yet about the seals.
What?
That's in the Arctic. As the ice is getting smaller, more of them are crowding onto the beaches, and so more of them are taking spaces higher on this fairly vertical cliff, but they don't know how to get down.
Oh.
And so it was always a problem where a few of them would fall. And apparently on Netflix now, there's like in the documentary just like a 200-foot fall of a bunch of them, and they just like watch it fall in slow motion. It became a thing people talked about, but I haven't watched the documentary.
It seems less like a documentary, more like a snuff film.
Well, it's Netflix is
getting into that.
They're
now.
trying to do the like they made it very much like let's actually look at some impacts of climate change.
Okay, yeah.
Like we have your money, so we don't need to worry about you complaining to the BBC about this.
It's not like in PBS where we're going to air the one or Discovery, they keep doing things where it's like, we're going to film a climate episode and then we're going to put it on after a holiday break, like 3 weeks after the rest of the show.
Let's bury it so that we don't end up with a bunch of Twitter.
I mean, there was the thing is, it's a sort of slightly different issue in the UK where there were debates about whether or not they should show lions catching and killing prey because some people were finding it disturbing.
We'd have more channels. There's choices.
Yeah, now we have cord cutting, so apparently you can watch seals fall 200 feet in slow motion if that's your thing.
I mean, if you really want to, you can then do it in reverse.
Oh, yeah,
It's
that's...
quarter speed.
Mm-hmm. Then you can save them all.
And then you can just go...
And if you then you have to put the Benny Hill music.
Okay, this podcast gets dark, but that was maybe a bit...
Yeah,
Thank you.
we did that session the first day. It's all going to be uphill from here.
Yeah, we're just talking about paleontology.
Oh, this was only really a 3/4 day.
Yeah.
Ugh.
So yeah, we gotta listen to some talk about snails. 2 talks about snails tomorrow. Yeah.
There were snails in this. They were pteropods.
Enough
Enough has been said.
has been said about how sad that's gonna end up.
Actually, and there's a couple of them that'll be okay, maybe.
Yeah,
In the Arctic.
heard that.
I think because that's going to be the new tropics.
No, pteropods
Pteropods are cold
pteropods
water.
are cold water. They're the ones that all those dissolution experiments are on.
Yeah,
Oh.
they're, as Rosie calls them, the potato chips of the sea.
Yeah, I remember.
And I use that every time I introduce ocean acidification to students.
Mm-hmm. I just show them corals dying.
Yeah, that's not why corals die, though.
No,
Yeah.
no. I don't talk about ocean
They actually
acidification.
don't acidify.
Well, so the acidification is a contributing factor, but like one of the major components is
Suntan lotion.
the rising temperatures causing their symbiotes to leave.
Yeah.
And suntan lotion.
Their organic matter acidifies the shell more than the ocean does.
Oh, you were talking about pteropods.
Yeah.
Yeah, okay.
Pteropods, if you give them enough food, some of the species seem to do okay. Like, so long as they have, like,
Say
a
that about
balance.
almost anything.
Sure.
If you give them enough food, they seem to do okay.
Yeah, so
You
they
say
can they
that
can
about
compensate. They can compensate and repair the shell faster than the damage is
Yes.
happening, like hitting on the
But-
shell.
but it is still
if they have enough food.
It's still a stress. It means that they need to eat more. It makes things harder, and it's harder if you get sick.
Mm-hmm.
All about multiplicative factors. Cool.
Cool.
Well, I guess that's probably gonna do it for day 1.
Yep.
And then we've got a day 2, and then we got a day 3 where nothing's happening.
Yeah.
So you're not gonna get anything done.
Maybe not.
Maybe not. Maybe something dumb like a picture of a pool.
Are you guys doing any of the Tuesday things?
No.
Okay.
Are you?
You?
I think I signed up to learn some kind of software.
Okay.
Cool.
I probably should have.
I don't need to learn things anymore.
It was expensive enough getting here.
It was free.
Oh, it was free.
I think that's why I did it.
Good job.
Yeah, no, you're way too eager.
Well, there was nothing else to do.
Don't
Is
you
everybody's
have-
going to Disney and
Don't you
stuff?
have work to do? Because that's what I'm gonna go to the pool
Everyone-
and do
No,
some work.
the person I need to work with is doing the session that's for the teachers, like
Oh.
Okay.
the climate change workshop for high school teachers and middle
I'm
school
gonna go to the
teachers.
pool.
So he's busy the whole time.
Yeah.
You don't want to stand in line waiting to get into the newly opened Star Wars?
Not much of it is open.
But that
It's
doesn't
still
stop
some-
there being a lot of people coming to LA for...
Mm-hmm.
Yeah. No. We could go to Avatar World.
Oh, that's the wrong side. You gotta be in
Yeah.
Orlando for that. We're
No,
gonna get
I
on
know.
a plane. We're gonna go
I'd do
to
it.
Animal Kingdom. We'll go to Avatar World. We'll stand in line for
Yeah.
2 hours to go on the one 5-minute ride, and then we'll get back on a plane.
Yep. Yep.
We'll have to drink the tapioca alcohol drink.
And we'll feel really good that we contributed to the Navi economy.
I feel really bad about contributing to the Navi economy, considering there's no Navi in that park anymore. I feel like the events of Avatar didn't end in the Navi's favor, if that's...
I mean, I'm pretty sure that it's very clear from the film documentary Avatar.
We're
that-
very... Yes, the documentary. We're very much off topic. Do you want to end this, James?
Yeah, bye.
You have to turn it off.
By the way, that could have been uncomfortable for me.
Yeah, I figured. You chose it.
I didn't choose